Right, let's take a look at some more challenging questions that you could get on areas and circumferences of circles. The type of ones that we're looking at now in this chunk are going to be the back end of your paper, up where you need to be a C grade candidate in order to be able to demonstrate you can do these. So the first one, question 6. Find the circumference of a wheel that has a radius of 16.7, giving your answer to an appropriate degree of accuracy. So a wheel is circular, its circumference, so we just write down C equals 2 pi r. Tells the examiner we're about to do the right thing. 2 pi times 16.7. Let's get that going on the calculator. 2 pi times 16.7, 104.9 or 105 centimeters. Either of those are appropriate. Anything more and you'd lose the mark. Right, part B. AB represents the front wall of a house, 11.8 meters long. The house has a semicircular patio in front of it as shown in the diagram. Calculate the area of the patio. Well, we know that to work out the area we need pi r squared, and we aren't given the radius here. We're given the distance from A to B. That would be the diameter. So the radius is going to be half of that. So let's do that first of all. So if we do 11.8 divided by 2, it's 5.9. So R is 5.9 meters. So if we work out what pi times 5.9 squared is, that is going to give us the area of a complete circle. We don't want the complete circle. This is a semicircle, okay? Half the area of the circle. So if we work that out first of all, we then need to divide it by 2 in order to get the area of the patio. So on our calculator, pi times 5.9 squared. So that gives us 109.4. Okay, but that's area of a circle, full circle, so we need now for the patio to divide that by 2. Alright, I haven't cleared it on my calculator. I'm just going to hit divide 2 and I get 54.76, but the next one is 5 or more, so that rounds up to 7 meters squared. Okay, so for a semicircle you just work out the area of the full circle and divide by 2. If it was a quarter of a circle, you'd work out the area of the full circle and divide by 4, and so on. Okay, question 7. What's the context for this? A circular mirror is mounted on a square wooden frame of size 12 centimeters, so that it touches the sides of the frame as shown in the diagram. Calculate the area of the wooden frame not covered by the mirror. Okay, so we need to get that shaded part. Well, again, we've got a circle there. We need to know the radius of it to find that area. It's going to be half of 12 is 6. So if we work out the area of the circle, pi r squared, bring that back over here, so we've got pi times 6 squared, so that's 113.1 centimeters squared. Now if that circle wasn't there, I'd have a square 12 by 12. So the area of the square of square would be 12 times 12, which is 144 centimeters squared. So let's have a think about what we've got here now. I've got a square with an area of 144, but in that square I have an area of 113.1 which is covered by the mirror. So the area that isn't covered by the mirror, the shaded bit, is going to be 144 less the 113.1. So area of shaded will be 144 less 113.1. That doesn't come very clear. Okay, so we do 144, take away 113.1, 30.9 centimeters squared isn't covered by the circle. Okay, question 8. A sports ground is in the shape of a rectangle of length 100 meters and with a semicircle of radius 40 meters at each end as shown in the diagram. Calculate the perimeter of the sports ground, stating clearly the units of your answer. So there we are, that rings the alarm bells, you need to give them. Right, let's see what we've got in this diagram then. If I hatch off the two semicircles there, what I've got is a rectangle in the middle which is going to be 100 meters that way, and if it's a radius of 40, that's going to be 40, that's going to be 40, meaning it's going to be 80 meters that way. We'll need that when it comes to the perimeter, the area. For the perimeter, well, what we've got is we've got 100 meter stretch there and 100 meter stretch there, and then we've got the circumference of half a circle there and the circumference of the other half of the circle there. So in fact what we've got are two 100 meter stretches plus the circumference of a circle of radius 40. So the circumference is 2 pi r, which is 2 pi times 40. 2 pi times 40. So that's going to be 251.3 meters plus the 100 meters there plus the 100 meters there. So we're going to add 200 onto that. 451.3, and the unit of my answer, it's distance, it's meters, it's meters. So 451.3 or 451 would get you the marks there. Then for the area, well, we've got a rectangle which is going to be 80 by 100, and we've got the area of a semicircle and another exact semicircle, so that's going to be the area of a circle. So we've got area is pi r squared, pi times 40 squared, which is 5026.5, plus the area of the rectangle, which is going to be 100 times 80. So if we do 100 times 80, we get 8,000, and then add on to that 5026.5, 13026.5, and its area, so we've got square meters. Let's just quickly track through that again. The shape that we've got is made up of a rectangle with two semicircles which make one full circle of radius 40. Perimeter is the distance around the outside. So I've got the full circumference of that circle plus 100 from there to there and 100 from there to there. The circumference of the circle is 251.3 plus the 200 straights to get that. And then for the area, it's the area of that circle plus the area of the rectangle in between. Okay, the final circle question that I found. This was certainly the very last question on the exam paper. We got two semicircles. The larger semicircle has got a radius of 8.6. The smaller semicircle would have a radius of half of that, which would be 4.3. The perimeter of the shape. So in order to find the perimeter of that shape, I'm going to need the circumference from there to there. So that's the circumference of a smaller semicircle. Then I'm going to need the circumference from there to there, which is the circumference of the smaller semicircle. But then I got to get back to the start as well, so I need to add on to it that 8.6 there. So the perimeter is going to be the circumference of small semicircle plus circumf of large semicircle plus 8.6. Okay, so the circumference of the small semicircle is going to be 2 pi times 4.3 times half, because it's a semicircle. This one is going to be 2 pi times 8.6 times a half plus the 8.6. Right, let's work out each little bit then. So 2 pi times 4.3 times half, 13.5, plus 2 pi times 8.6 times half, 27.0, plus 8.6. So I got 13.5 plus 27 plus 8.6 equals 49.1. It's perimeter, so it's length, so it's centimeters. Okay, and then for part B, the area. Well, the area is going to be the area of the large semicircle plus the area of the small semicircle. So the area of A will be pi times 8.6 squared times a half, because it's a semicircle, so you've got to half it. So that's going to be pi times 8.6 squared times your half, 116.2, because the next one is 5 or more. Area of B will be pi times smaller radius, 4.3 squared, times a half, because it's a semicircle. Pi times 4.3 squared times half, 29.0. So we're going to add those two up now. So we've got 116.2 plus 29, 145.2, and the units will be centimeters squared. And just notice there that this question, they want the answer to the nearest whole number, which is going to be 145 centimeters squared. So it's really important with areas, with perimeters, that certainly with perimeters, you're clear about the path that you need to take to go from wherever you choose to start all the way around the shape and back again. Very, very easy to have forgotten that, adding that 8.6 centimeters at the end there. And that's about as tough as those circle questions can get.